good afternoon, everyone, and welcome. My name is Robin Shirley, and I'm going to be your moderator this afternoon. And a very big welcome from all of us at Regenesys to the Artificial Intelligence Masterclass. We're really excited to have you all join, so thank you so much. Our purpose at Regenesys is really about awakening potential. And we do that in a number of ways. But one of the ways we do that is about creating and sharing knowledge. And this is where these masterclasses come in. We're all facing a new world and a new normal, which I'm sure you'll all agree with me, with the COVID-19 pandemic. And as leaders, we're finding ourselves in a whole new space to navigate. So now is the time to really start looking at having these conversations about the impact of different factors on our new world and ways of working. We're very fortunate enough to partner with our campus in India to bring you some amazing thought leaders to engage and share their knowledge with. So I'm very excited to introduce you to our facilitator in a little bit. But before I do so, I just would like to go through a couple of housekeeping rules, if you would allow. So we're thrilled to have you all here. There is a lot of you on this webinar, which is amazing. And we see we've got students represented from over 190 countries, which is amazing for us. So this truly is an international experience for us. We do ask that we have muted your mics, and we do ask that you stay on mute just so that we can hear the facilitator correctly. We do, however, want to hear from you. So please do engage. You will see there is a Q&A button at the bottom of your screen. So please, if there is any questions you have for our facilitator, please do put them there. What I will be doing as your moderator is I will be scanning those and making sure that once the presentation is finished and we have a bit of a Q&A session at the end, that I cover some of the key topics and key themes that are coming through from the group. We really do want to capture your thoughts and what you guys are thinking, so please do stay in touch. But without further ado, I'd like to welcome this afternoon Mr. Vaibhav Patel. And he is the co-founder of iNocular, which is a AI customized solutions company. His background is in electronics engineering, and he also has an MBA in finance and strategy. So I'm sure you will all agree with me that we're in very, very capable hands. So without further ado, please join me in welcoming Vaibhav. Good afternoon.
Good afternoon, Robin. Thank you for the kind words. And good afternoon to everyone who's online. I think we've got about 260 participants. That's phenomenal. It's a great turnout. So thank you, Regenesys, for helping reach out to so many people. Now, as Robin said, and you all know, we are in the middle of a very, very big crisis. It's unprecedented on so many levels that most of the companies have felt that they are unprepared to handle any of this. And once this crisis subsides, we are going to see that a lot of things are going to change in the business paradigm. And when they change in business paradigm, they're going to end up changing for a lot of us, as employees who are working with all these companies. And when we look at that level of unprecedented change, we also have to look at how are we going to do things in a better way going forward, so that we are able to cope up with the impacts of this COVID-19 and any other calamities that come. So what it's going to boil down to essentially is businesses will become more efficient in the way they do businesses. So that would mean costs will be cut, unnecessary expenditures will be driven down. You would see more efficiency in operations, sales, and pretty much every single business area. And which is also why I think this series of masterclasses is a great way, because technology is driving most of the efficiencies, I would say a lot of the efficiencies in the businesses these days. So today's topic is about how AI is going to drive those efficiencies in businesses, what AI is, and why there is so much talk about it in the world. If you look at it everywhere, everybody is talking about AI, calling it a revolution, and so on and so forth. So what we are going to focus today on is a non-technical look at what artificial intelligence is. I understand most of the participants here are not from a technical background. So I promise you I'm going to be really, really light on the technical stuff. We are going to discuss artificial intelligence as it will affect most of the people in the world outside the technical community, and how to deal with that, and how to prepare ourselves to be ready for the changes that are that are sure to come in the future. So I have a very light presentation that I made to just help keep us on track. I'm just going to be sharing my screen in a minute. And then, all right. Can the moderators please confirm if my screen is visible?
Yes, thank you. We can see your screen.
All right. So let's get started. Now, when we talk about artificial intelligence, what I usually start with is, if you look at history, we have seen certain technologies and certain new processes from time to time that have fundamentally changed the way we work, or that have fundamentally changed the way business is done and our lives are governed. So if you look back, there are technologies like the telephone, which fundamentally changed the way people communicated. Then there were the computers, which fundamentally changed the way information is captured and stored and what we can do with it. There have been smaller waves of technological advancements that came and went. But only once in a lifetime does a technology come that that has an impact on such a wide range of industries and such wide aspects of our life that it becomes truly a game changer. So I feel personally that AI is one of those technologies which is impacting every single aspect of our lives, every single industry that is around. And that's why we feel that, we should have this session to start with. Right. So what are we going to do in this session? Quickly, 5 pointers. We are going to talk about why AI is important. Why should we talk about it? Why should we learn about it? Then we are going to dive into a non-technical introduction of AI, like I promised. Then we would try to understand why AI has become so disruptive. Why is it changing so many things around us? And why is the impact so high? The next point would be the most important, is we'll have a look at how this AI is going to affect organizations and employees, and therefore all of us. And then we will end with some pointers on how can we, as non-technical people, uh, uh, prepare to cope up with this change, right? So let's get started. So why should we talk about AI? I said that it's a once in a lifetime technology change that's affecting everything. So don't take my word for it. So that's why I like to start with this slide every time. This is nothing but a clipping of news from around the world, which talks about what AI is doing. So you can see AI here. If you start from top left, AI-driven chatbots are changing customer service in all industries. AI is helping you detect breast cancers in radiology reports. AI is, of course, the backbone of self-driving cars. Companies are using AI to curate recipes. Up here, what we've got that next year or very soon. So this is a little bit of old news. It says AI will be taking your job interview next time you appear for one. Then we've got how AI is helping approve your loans, even for people who have no credit history. AI is also generating music. AI is also changing the face of war as we know it. And last but not the least, you must have heard of Cambridge Analytica. Cambridge Analytica is a company which used sophisticated algorithms, which supposedly used sophisticated algorithms to alter the outcome of two major elections in the world. And they have been under a lot of fire recently. So if you look at this picture as a whole, AI is literally impacting every single industry that's out there. It's impacting how we interact with companies. It's interacting our health. It's impacting our health. It's impacting how we drive, what we eat, what kind of tastes we like. It's impacting our jobs. It's impacting how we get loans. So finance. We've got arts as well, where AI is being used to create art, music, and novels and such, and war, and last but not the least, politics. It's changing the way we interact with government. It's changing our societies fundamentally. So it's a lot to take in, but that is also precisely the reason why we should be talking more and more about all of these things. So the takeaway from all of this is, if so many industries are getting impacted and so many industries are getting disrupted because of AI, it's sooner and not later that every one of us will find ourselves dealing with AI. Actually, if you think about it, if you have used Google, if you have used Facebook, if you have used Uber, if you have used any of these modern social media and other apps, you have already dealt with AI. If you have used a chatbot, you have dealt with an AI. So mark these words, it will be sooner than you think, but we all will be dealing with AI, and it will be impacting everything. Right. So before we get into more details, let's have a non-technical introduction to AI, what AI is exactly. Now, mind you that when I'm going to explain this, I have simplified this a lot, considering a lot of us don't know technical jargons as well. It's a huge subject to understand how AI works. So we have really simplified and taken a gist of it to give you a working knowledge of AI. So if there is a discussion on AI, you should know what AI does, how it works, and what are the capabilities and what it cannot do. So that's the purpose of this section here, right? So let's start. So for starters, a definition, don't worry too much about it. We're not going by textbooks. Basically what AI or artificial intelligence is it simulates human intelligence. So it's a computer program that simulates how human intelligence works. And it does by following three processes, which is learning. So basically we capture information, we understand the rules for using those information. So we collect information, that's learning. Then we reason. So there is a reasoning which says, I'll use the rules that I picked up to make conclusions. So we take data, we use reasoning, and we make conclusions out of it. Exactly what has been mimicked in AI. So an interesting fact is AI is actually based on something called as neural networks. Again, don't worry too much about the technical jargon, but neural networks, the design of neural networks was inspired from something called as neurons, which form the decision-making part of our brain. So when neurons connect to each other in our brain, we share information and we connect information to each other and we make a conclusion out of it, or we make a decision. So that's how AI also collects data, learns it, uses reasoning, and then gives a prediction or a decision. It also has a self-correction mode, just like us humans, where if the decisions are wrong, we go back and update our original learning and say that, this information that I captured wasn't enough or was wrong, and that's how this works, right? So In short, it's mapped completely like our brain. It's supposed to work like our brain. Now, let's take a very, very simple example, extremely basic, and then we will go deeper into it. So consider you're talking to a baby, a child, and you are teaching the child today's subject is identifying animals. So you tell the baby, you show him a picture of a horse and tell the baby, this is a horse. Here's a second picture, that's also a horse. And there's a third picture, that's also a horse. So if you do this enough number of times, the baby starts learning, the child starts learning what a horse looks like. So what is it doing in the background is it's actually creating certain patterns in its mind. It's trying to find similarity between these three pictures and trying to make an opinion, make a reasoning in its mind that, okay, this is what a horse looks like. Maybe it has 4 legs, a tail, 2 ears on top, and a longish face. So perfect, you train the child that, this is what a horse looks like. And then you show him this pic. And there is a very good possibility that the child will come and say, it's a horse, but it's a donkey. So you again go back and teach the child, no, this is a donkey. So now the child is confused. What has happened is there were a certain patterns that were calculated in the child's mind of how a horse looks. So 4 legs, a tail, longish face, and 2 ears. And they reflected exactly in what a donkey looks like as well. And that's why the confusion. But when you show comparatively that this is how there is a difference between these two animals, the mind again starts relearning, retraining itself that, okay, a donkey and a horse probably have some broad features similar, but there are subtle differences. These subtle differences are learned by the mind that, okay, the donkey probably has a shorter stature, not as majestic, slightly different tummy, xyz, whatever. So what is happening is the brain is subconsciously creating certain patterns in your mind, and using those patterns next time is what you will get a correct decision. So it's exactly like a child. You teach the child, you train the child on this is a horse, this is a donkey, and this is a horse, this is a donkey, and eventually the child learns. This is exactly how a AI algorithm works. So this is a very, very simplified diagram. Let's start from the top left corner. What we are doing is, if we have to train an AI algorithm about identifying a horse, how do we go about it? So we give a bunch of training data, which is a bunch of images of the horse, into the AI algorithm. There we perform a training. It's actually called training an AI algorithm. In the training, what happens is the algorithm looks at all these images and it tries to derive similar patterns that are present across all of these images. Then it stores those patterns and those similarities and the rules associated with it. It stores them in something called as a model file. So let's consider that it's a file in which all the rules and patterns and similarities are present. Now, when someone is building this algorithm, we do not tell. So this is the most important part. We do not tell the model what similarities to find. The model is intelligent enough. The way it has been written, it's intelligent enough that it finds its own similarities, it finds its own patterns, and it makes its own rules. So this model file, the AI model file that you see on the bottom, will contain all these rules saying if a picture is to be of a horse, it should have X, Y, Z, and ABC. So once the model is trained, that's where you now start using it to get decisions. So let's say I picked up a new image of a horse and I fed it to the AI model. The model will then compare this image with known patterns from the model file. And once it finds enough similarities, it will give a prediction. The prediction would be it's a horse or it's not a horse. Well, it's not that simple. When it's a prediction, it comes with certain probability. So the model will tell you that I'm 90% sure this is a horse. And that's how you are training the system to learn to identify a pattern or an object or any piece of data, and then using it to derive decisions out of it, just the way a human brain works. Now, if the pattern made a mistake, you give it a feedback that you identified X image as a horse, but it's not one. That's where it goes for the retraining loop. So what you see here is that image gets sent back to the training data set. It's reanalyzed. The patterns are reanalyzed and reconstructed, and a model file gets updated so that the same mistake does not happen again. So when you are looking at an AI algorithm, this is the exact process. You build an algorithm, you train it with training data, and then you use that algorithm to derive decisions out of it. Right? So very, very high level, very simple. Just a few jargons that I gave you. One is training the algorithm, models, to store all the patterns, and what AI does is it basically it identifies patterns on itself and then creates a rule, right? So how do we do this in practice? So we are certainly not dealing with horses. So here is an algorithm that Inocular, our startup, has developed for identifying grocery items in a supermarket. So this is from a proof of concept. What you see on top are 4 images of, so I think this is a toilet cleaner from the brand called Harpic, right? So we want the algorithm to identify what a Harpic looks like. So we gave it these 4 images and a few more. And with each image, we kind of told the algorithm that this is how a Harpic looks and this is how a Harpic looks. What you see on the bottom, the one image, is the actual algorithm in action. So when we took a video from top, so what you're seeing is a video taken from top, and we have placed a bottle there, and it has identified the bottle as Harpic. Mind you, the brand name is not visible. None of the labels are visible, but still, with a high accuracy, the model is telling us that this is a Harpic. You can also see there is Dove soap on the corner. It has been trained similarly. Now, what has happened here? When we trained the algorithm on top 4 images, we did not tell it that this is this is a bottle, this is the label where you should look for when you identify a product. Just like our mind would do, it identified that a blue bottle with a red label, red cap, with that kind of shape is a very high chance of being a Harpic bottle. So this is how you put AI algorithms in real world use cases. So how this algorithm is going to be used is it's going to be used in supermarkets, at self-checkout stores, at self-checkout counters, where we are going to, one of the biggest problems for supermarkets at self-checkouts is a lot of items don't get billed, and they lose a lot of business and money behind it. So this solution is developed to help those people identify what all items were in the cart, what were taken out and put in the bag, versus what items were billed in the system by the customer. And therefore, what is the difference if there is a loss of sale happening or a theft happening, and so on and so forth. And the the applications of this kind of algorithm are very widespread. So technically, we could also take a picture of the aisle and figure out what all products are on the aisle. Where are they? Where it should be? Is there anything that has gone on stock out, and so on and so forth. So this was to give you an idea of how we take that concept of learning and training and making decisions, bring it to a real world scenario where we are saying we are now identifying everyday objects. Now the same concept, the same logic can get extended to any number of use cases. Now, let's take a moment here before we go forward to understand what it is doing, what this algorithm is enabling. There are a lot of ways, we have a lot of ways to capture information. So while you have been working in your respective jobs, you would have captured information in a lot of ways. Most often, you enter it in a system, in a database, or in a ERP, or in a spreadsheet manually. There are also certain sensors available which capture certain data. For example, you can measure temperature using a sensor. But if I were to ask you to look at a bottle and tell me if it's a Harpic bottle or not, that kind of measurement was not possible till now. And we'll look at why. So all the computer systems and applications and systems, anything that runs on a computer system is written in a software program. And these software programs follow a decision tree. So basically it's a big if-else list of commands. So it says, if you find this, if you find this, then do that. If you find this, then do that. If you find Z, do A. If you find X, do Y. So all the possible scenarios that could happen with a certain activity have to be listed in the program. And the computer needs to be told what to do when any of these actions happen. So this is a decision tree model on which most of the applications work, most of the computer programs work. It's structured data. So it's really good to capture structured data. But when you are capturing unstructured data, like identifying something off of an image, or trying to understand what somebody is saying, trying to understand speech, for example, this is unstructured data. There are hundreds and thousands of combinations, all of which cannot be really coded and listed down and put into a program. For example, there are infinite angles through which you can look at this bottle. Will you take it would be really impossible to take a photograph from all angles and then feed it into a system and then try to decide what it is. Or when that image comes with another product, it increases the complexities twice as much. So what AI is helping you do is, AI is helping you capture the unstructured data that has been impossible before. It's helping you recognize patterns that humans also cannot see sometimes. So we are not telling the programs how which patterns to look for. The program itself goes through the images and it finds the common minimum across all the images and learns that this is what this pattern is what makes Harpic unique, or this pattern is what makes a horse unique. And that is why AI is that revolutionary. So when we take this same logic, we can apply it to any industry, any problem that's out there. So we are also going to look at some broad classification of AI algorithms and how they are used. So first classification is something that's called as expert systems. Again, don't worry too much about the terminology right now. This is a very introductory course. So what expert systems do is they find patterns across a large range of data or systems. They use the knowledge base created for any system and give judgments out of it. So things which can be broadly classified under this is applications in finance. For example, the first headline that we saw, AI is helping assess whether to give loans to certain people, and especially certain people with no credit history. So it's very interesting how this is done. One of the applications that does this is, what they do is, they take all possible data about a person with no credit history, right? So the normal loan process is you take a loan application, you find out the person's credit history, and you approve or reject the loan based on a credit score. But if you don't have a credit history, what you do is you collect data of loans given to people with no credit history. You collect as much data about them as possible. So this could be from multiple sources. This could be employment history, This could be your social media profile. A lot of companies are doing that now. This could be, say, your driving license records, how many times you break signals and rules, and so on and so forth, and combine this information and give it to a system. So there would be a list of people which, say, the training data would look something like this. There will be a list of people who have been given loans. Some of them have defaulted, some of them have repaid, and there will be social media data, employment history data, and, say, driving, your driving license data with it. Just some broad examples, right? Now, what the AI will do is it will try to find patterns for the defaulters. So, for example, if there are people, if it finds that people with high driving license fines plus very aggressive social media behavior tend to default more than those who are calmer and more rule abiding, it will identify those subtle patterns in your social media profile, in your online behavior, in your social behavior, and build a model that will be able to predict who are more likely to default. So next time when somebody walks into the bank, if I can feed all this data to the AI model, the model will be able to give me a prediction of whether this guy will default or not with a certain confidence level. Confidence level is what is the possibility that the AI thinks this will happen. So it will say, if it says 90% confident that this case is more likely to default, the business can take a decision. So imagine all the paperwork that happens behind the screens to approve a loan has now been automated at a much higher accuracy level that we cannot achieve. Same goes for food companies. So what food companies are trying to do is interesting. They're saying that if I know that 10 out of my 100 products work really well with customers, I can create a flavor profile that is most likely to win. So I'll develop my next product based on the unique flavor profiles present in the 10 winning combinations, and I'll see if that works together. Not a perfect science. There is a probability associated with it, but a great way to reduce experimentation, a great way to reduce development costs. Same goes with Cambridge Analytica. So this is also called social engineering, where you're trying to alter people's behavior and their thought processes based on the information that is served to them. So those of us who are into watching Facebook videos a lot, and if that's the only source you're watching, Facebook can actually game the kind of videos that you are seeing, and therefore help shape your worldview, your view about a politician or about a party, and so on and so forth, and therefore possibly impact outcome in the elections. So the two major elections where these guys did this was the Brexit referendum and the election of the US president, the last US president. That's the accusation. And they used Facebook data from it. So there is a very great documentary called The Great Hack. It's a brilliant documentary that talks about this and how they use this information to alter human behavior. If you get time, do watch it. The next type of AI algorithm then is something called as natural language processing. So basically, this type of algorithms, they try to understand how speech works and how languages work. So even if I tell you the meaning of each word independently, when these words are combined into a statement, what do they mean? So when you're typing in Google, say best pizza restaurant near me, the algorithm has to understand that you are looking for a pizza restaurant. So it has to translate that into a query that it will go back to its database and fetch the data. So that's what natural language processing does. Again, same principle at work. You give enough tapes of conversations to the AI algorithm as training data. You tell the algorithm what this data is supposed to mean. It will learn and it will try to find similarities in all these conversations and these statements, and it will make its own pattern. So next time when you give it a statement, it will understand, it will predict what you're trying to say. The same logic is used in Alexa, Siri, all these voice assistants. It's also used in chatbots. So if you have ever gone on your bank website or telecom website and had automated responses on the chat screen, it's a AI algorithm at work behind it. So they're also now trying to see if they can use this to understand, say interviews or phone calls. So Google sometime back also demoed a very interesting application where if you want to make a booking to a hotel, you just tell your Google Assistant and it will make a call in a human voice. It will speak as if you are speaking and make a reservation and confirm it back to you. So all of that is called natural language processing. The third and a very big part of AI algorithms or segment is something called computer vision. Uh, Computer vision basically gives the algorithms ability to see and recognize objects from a video or a still picture, and you would have seen it all over. The biggest application of this is, of course, the self-driving cars. So what self-driving cars are doing essentially is with the knowledge that we already have about AI, we can explain it very well. So the cameras on top of the self-driving car are always looking outwards in all directions. They are identifying humans, other vehicles, obstacles. So how do you achieve this? You again train the system with enough images of humans walking on the street, with enough images of other cars and vehicles, and enough images of obstacles. And as you can see in the bottom left picture here, the system will start recognizing humans and obstacles. And so what these cars do is they have cameras trained everywhere. They keep tracking who's around you, in which direction are they moving, and then they plot if a car is moving in this direction from left to right and I'm going straight, how much time will it be till we cross? And if we are going to collide, I'll reduce my speed. That's the very, very basic way in which a self-driving car works using AI algorithm or a computer vision. There are, of course, more complex problems to solve, and it's a huge field in itself. Then there is one very interesting application of computer vision is in radiology. So there are these scans, X-rays, CT scans and stuff. So a lot of people are building algorithms where the algorithm, if it's given a scan, it can detect early stage cancers or metastatic cancers. And it is said that the accuracy coming out of these algorithms is much, much better than a radiologist doing it manually, and the variation that you will get from one radiologist to another. So if we can detect cancer early in its early stages before it becomes malignant, that's a great achievement. So these are the three very, very broad segments in which AI algorithms can be divided. This was to give you a starter pack of what a AI algorithm is, what it does, and how it works on a very, very high level. It's a very deep topic, but you don't need to be very technical to understand how it works. And the whole purpose of this session is to give you that knowledge without getting into technical details, right? So now we have, on a very, very high level, understood what AI algorithm is. It will be interesting then to understand why is it that it's causing so much disruption. So imagine if there are 100 call center agents and they are asking answering queries. For example, if you call an airline and ask the customer service, when is my flight delayed? My flight number is XYZ. Is it delayed? It's a very objective question to answer. And imagine 100 callers, telecall executives are doing this work. Now with natural language processing, if you can actually answer these questions immediately over a chat, or even in some cases telephone. What you're doing is you are suddenly automating a large part of your workforce, making it at a very fraction of a cost that is bound to cause disruptions. How will it be disruptive? It will be disruptive because running a call center is a huge cost for a business. It impacts how the business grows. It holds down profitability and so on and so forth. But if you can remove that cost overnight using an algorithm, that's a game changer. So anybody who does that will have naturally an advantage over its competitors. Similarly, this applies to all other industries and use cases. That is why the impact, the potential impact of these algorithms is such large that we are calling it a disruptive innovation. Now, why is it so disruptive and how did it evolve? Let's understand a little bit about the background of how these things work, right? So about 4-5 years ago, 5-6 years ago, actually, AI was still a research project. It was being pursued as research, trying to mimic human intelligence. The motivator and the financer, of course, is businesses. And why are they interested? Because running a business is all about making the right decisions, making better, more accurate, faster decisions than others, so that you can get maximum sales, maximize profits, and so on and so forth, right? So that's why businesses are interested in this. So quick trip back in history. Let's go, say, 70, 80 years back in time, where and look at how businesses make decisions. So before we go back in time, the general structure that all of you know is, how do businesses make decisions? They collect data, they give it to the decision maker analyzes that data and gives you a decision. So the data collection can be any number of sources. The decision makers are usually the management or the managers or the employees, and that's how you take decisions on a day-to-day basis and run the company. So if you go back in the history, say 60-70 years ago, when IT systems were not that prevalent, both these roles of collecting data and making the decisions were done by humans. So basically what happened is, if somebody is running a grocery store in the city, people valued, and we still value, experience of that person. Why do we value experience of that person? Because that was the one of the only ways at that time to capture information. What information is that grocery store owner capturing? How many people come, how many of them shop, what is the trend, and what are the patterns in the buying behavior of customers, what products work, what don't work, and so on and so forth. So we value experience because experience is basically data stored in our brain, right? And then that data was used by the store owner himself, in this case, to make decisions out of it. And that's how most businesses were run back then. But then there are a lot of issues in this. What are the issues? Humans have very limited memory. Although we are very, very creative and we have very sharp brains, we have limited memory. We get bogged down when large sets of data come our way, right? So, and when we have to recreate that information, recollect that information, we sometimes miss out on things. So the accuracy takes a hit. So to solve this, our brains try to simplify information. And when we simplify information, it's something that we like to call as thumb rules. So we try to simplify and create thumb rules and equations in our mind that say, if this happens, then this is what you do. If X happens, then Y is likely to happen. And we establish a relationship between these two. So thumb rules are great. Thumb rules are great when they are able to, when they are they are being used in a very broad sense. But that's not how businesses can run, right? Plus, the third problem with this decision making is that we have inherent biases. So there is a huge line of study that you can check for cognitive biases that will tell you that we tend to take certain decisions even when the data says something different. For example, if two people came for interview, one is an extrovert, one is an introvert, we would subconsciously try to favor the extrovert guy, regardless of what the data shows. And the data might show that the introvert guy who speaks less is more able to do a certain point of work. So we are marred by biases. We are low on accuracy. We can't deal with huge information. Those are the issues when humans are capturing and humans are deciding. So then came the phrase, the internet age, the IT systems came in, and this new phrase came in, you must have heard, it's called data-driven decision making. So what data-driven decision making did is it replaced humans in that data capture phase with IT systems. So we collected hundreds and thousands of millions of rows of data. We combined it with information from computer sensors and so on and so forth, use databases, ERP systems. We drilled down that information and then we gave it to a human to make a decision. But again, the decision maker is also a human. So he also has the same shortcomings. He cannot look at huge data. So we go back and we simplify the data. So a lot of you would be making pivot tables and reports and dashboards to simplify that data to give it to a decision maker who will then find patterns in it and take a decision, right? But again, same problems exist because there is a human in the decision making chair. What is happening is when you are summarizing the data under certain heads, it's losing granularity. So for example, if I say that on an average, every day, 10 people walk into my store, I'm losing the granularity that maybe out of 10, 7 walked in the first half of the day, and only 3 walked in the second half of the day. So averages are very misleading. So when you summarize data, when you take sums or averages, it loses the granularity and certain patterns. Now, how you summarize data is also very important. For example, if I'm for those of who are in retail, the metrics on which retail business decisions are taken is footfall, conversions, and sales. So whoever is telling you to summarize the data also has those inherent biases that these are the 3 metrics that matter. And these 3 metrics, these 3 patterns, if we analyze, we can make better decisions. So what's happening is you are actually not analyzing all the granular, small, minute patterns that might be affecting your sales, that might be affecting your footfalls and conversions in your retail store. And the same with, say, giving out a loan or understanding what a customer is saying. So that is where the AI algorithms come in. So what you're doing is you're keeping the AI algorithm in the decision maker's chair so that it can identify those minute patterns and give you a more accurate result. Right? That's where this all started, and that's why it's going to happen. Now, looking at this picture, it looks kind of scary where you have removed the human from the data collection point, you have removed the human from the decision maker point as well. That's doomsday scenario. Does that mean, we're going to lose all the jobs? Well, the answer is no, because while AI is very good at taking certain decisions, it's still dependent on measured data and structured data. What we humans have that's not with the AI is the understanding of emotions, the creativity that is associated with creating, taking strategic decisions, making vision statements and mission statements, and then channeling all our resources behind it. So when it comes to structured data and decisions related to it, yes, AI is probably performing better than humans, but we have certain unique things that are still on our side. That is what we, that's our unique factor against AI. Right.
I hate to interrupt you, Vaibhav, but we're going to run out of time if I don't stop you there, unfortunately.
So I think I have some very important points pending. Let me just rush through it.
Sure.
Sorry, I spilled out of the allocated time, but this is a part that's really, really important. So awesome. If you could please give me another 5 to 10 minutes, we will quickly cover it up.
Sure.
Is that fine?
Thank you.
All right. So, sorry guys, I'm going to increase my pace a little bit. It's a very vast topic, and I tend to spill over. So, is AI going to replace humans? Certainly not. But what is the impact on businesses and employees? That's what we are here for, really, right? So remember when we said that sooner than later, you will be finding yourself dealing with AI at work and in your life as well. So what is going to happen? What's the impact on jobs? Is it a doomsday scenario where everybody is going to lose jobs? See, let's be very clear. There will be impact on certain jobs. The impact can be in terms of some jobs being redundant. For example, repetitive tasks, which are low value added and transactional, are very easy to automate with AI. So there might be certain cases, a small set of use cases where there is redundancy. In certain other cases, it is going to end up empowering most of the roles. So if you look back, most of the things that people complained about, most of the technologies people complained about in the beginning, they ended up becoming indispensable part of the work. For example, a lot of people thought computers are going to take everyone out of job, but today you cannot work without a computer. That is what is going to happen with AI. It will also mean a lot of us will have to reskill. We will have to change what we are doing, learn certain new skills to cope with the changing business scenario. It is also going to create a lot of new jobs, not only in technology, across business verticals. For example, social media selling was a non-existent job 10 years ago. Now a social media manager is one of the prominent roles. Similarly, you will have many more roles. It will also create bigger opportunities because what is happening is a lot of companies are using AI as their core and trying to disrupt industries. They're trying to gain market share. So naturally, they would need more workforce and they'll create new jobs and new opportunities. It will affect low value added activities. The same has happened in history. If you look at every new technology that came in, it disrupted something. The industrial revolution put out people who were working by hands. They were replaced by machines. So the idea is, don't get scared that AI is going to take away jobs and it's going to have a bad impact. Understand what is going to happen and reskill yourself. So remember the three things we talked about. We have creativity, we have, we can understand emotions, and we have vision. All of those can be used then to work with AI, right? So we'll quickly move forward. This is a simple metric that I feel is going to be the future. You are going to be all of us are going to be in one of these boxes in a very short time. Either we would be in a business which has been disrupted by a company which uses AI. For example, if a company starts disbursing loans based on AI algorithms, then the incumbent banks will be in trouble. That industry is going to get disrupted. So you're going to be either part of a company which gets disrupted, or you're going to be part of a company which is disrupting the industry using AI. So you'll be one of these. You could be the one who is deciding how to implement AI, whether to implement AI or not. So in a management team, you could be one which is designing a solution, AI solution for your business, and saying, what would work best for us. You could also be one implementing it, or you would be the end user of a AI solution. Or worst case, you would be the one who gets redundant or replaced by AI. It is bound to touch all of us. Then what's the impact on businesses? So this is again a huge area of using AI as a strategic tool. And a few pointers here is, there are bound to be new entrants which will disrupt your industry. So you have to rethink your business model. You have to rethink your strategy on how to use AI as an enabler. So far IT has been an enabler. Now AI is going to be the next enabler for businesses, business innovations. How do you achieve that? Core industry knowledge was the key so far to rule an industry. That is gonna get diminished. So very interesting example is when Uber needed a new CEO, they did not hire a person from a cab company or somebody who ran a rental company, car rental company. They hired a guy who used to run a digital business from Expedia.com. Now imagine CEO of an organization that high is not placing the bulk of its requirement on industry knowledge, but on a strategic thing related to digital businesses and AI. So that core shift in thinking has to happen. Once this is happening, naturally the adoption of business AI by businesses will significantly increase, and it will all trickle down to what we are doing. So the last section of the masterclass is then how should you prepare? How should you prepare yourself now that we know that this is an impending change? It's going to happen any which way. We better be prepared. The first and the most important thing, stop protecting the status quo. Stop resisting that I do not want to change. Stop resisting that AI will bring a doomsday scenario, take away all jobs and blah, blah, blah. Maybe Skynet will take over the world one day. Stop doing that. Anyone who has done this in the past, across all the revolutions in the history, they have vanished. So the only sensible thing that we can do is be part of this, understand what's happening. So when we say understand what is happening, I don't want you guys to think that you have to learn coding or be a software engineer or start writing AI algorithms. You need to understand how AI works in detail, not technically, but from a business point of view, depending on what role you are doing. You need to then identify which one of these boxes you fall into. Are you the one who is getting disrupted? Or are you the one who is going to be part of a AI project very soon in your company, right? Once you understand what is happening, how AI is working, how it will be applied in my role or in my company, then you go on to the reskilling part, where you say, I will learn the relevant skills if I am at risk, or if this is going to be the next big thing, shouldn't I be part of the AI projects in the company? Now, does that mean you have to be technical? Again, no. You need to find a way to use your knowledge, your existing knowledge, to work with AI. See, we cannot resist AI, the change that is coming. So we have to work together. When we said that AI is good in taking certain decisions and humans are good in taking certain decisions, nobody is going to replace anyone. These two decision makers are going to work side by side. When AI gives you a certain, handles a call in a call center where a customer is asking for a flight is delayed or not, it's a yes or no answer. That's great. But AI cannot handle an angry customer shouting on the phone. That's where your emotional quotient is going to come in. That's where humans are going to make the difference. So did all those people in the call center lose their jobs? No. They moved to more value-added activities where they are now using their real skills to do a better, more value-added job. Be very, very clear on these points. You have to find your knowledge, a way to work alongside AI, and having business knowledge helps a lot whenever we interface with customers. We build new projects. It's the people on the ground in the middle management who have the knowledge about the business, how things work, that help us define how the AI solution would work. So you would, the best possible chance is that if you're not using an AI solution, you would be the one who's going to help the technical guys design one. So change your mindset accordingly, accept the change that's going to be there and be part of that change. Once we, change our mindset that way, that's all it's going to take. And, years later, when we look back, we would be probably talking about another new technology, and we might refer back to AI saying that was the last big revolution that changed everything. So I'm going to just wrap up there quickly with that thought. And over to Robin.
Thank you so much. I can't believe the time went so quickly. Thank you for breaking those concepts down for us and making them so relatable. I really enjoyed your examples with the horse versus the donkey and how the process works. It's fantastic. So thank you so much for sharing that with us. For everyone on the call, please don't panic. We have recorded the call. So I know there's been a couple of network issues for some people. We will be sending you the recording with the email address you registered with. So please be on lookout for that, as well as some communication, because this forms part of this masterclass as one section, but we have an actual introduction to artificial intelligence course, which we will be running, which will really navigate this space a bit further and look at how we can work. You said it beautifully, how we can use our knowledge to work with artificial intelligence. So please have a look out for some communication from us. We will be sending you that information. And as part of attending this masterclass, you will be entitled to a discount on that program as well. So please do look out for that. We'd love to have you to join us with that. But unfortunately, we're out of time for questions. But I think looking at the questions that were coming in, you really did cover that in terms of the human factor. Where do we start? What does that mean for us? So thank you so much once again. We've absolutely loved spending this afternoon with you.
Thank you. Thank you so much, Robin. And thank you, everyone, for joining. And thank you for your time. I hope I answered, made the basic concepts clear. It's a huge subject. What we tried was to create a high-level overview to give you a direction. We will see if we can answer some of the questions later as well. Sorry for running out of time, Robin, again. And it was lovely talking to you all.
No problem. We've loved your passion for this subject. So thank you so much. It's very difficult to condense it in this time. So we understand that completely. But thank you to everyone for joining us. Please, as I say, look out for the communication. We'll summarize some key points for you and send you some more information about our program as well. But thank you so much from all of us. We've loved sharing this masterclass with you. Have a wonderful evening further. Bye.